Okay, friends, in this last little video, we're going to take a look at, again, some examples of when you shouldn't use averages, medians, modes, things like that. So this was a fun example that popped up in my class a few years ago. I was teaching Math 95 at the time, and I gave an exam to 63 of my total Math 95 students. And as I used to do back then, I kept track of certain statistics. Like, for example, their grade on average was 71. And their median was 78. So the average was a little bit low. So based on what you just saw about skewed distributions, you might think, okay, this might look like those houses where you've got a tail that's shooting off to the left instead of the right, and the median's to the right of the average. But as far as going left, the minimum grade, no lower than 50, and you couldn't get back, nobody got higher than 100 on this exam. So if you think about this, you might say, all right, which measure should I use? Should I use the average? Should I use the median? Well, what I did was I actually grouped the exams into a histogram so I could look at them. And that's what it actually looks like. I had to chuckle when I saw it because it reminded me of Ronnie James Dio and the Heavy Metal Hand. Horns up! And I began to realize that there's no way I should use either the median or the mean, because look at where they are in the graph. As a matter of fact, what I should do with a graph like this is not use median nor mean, and instead look at those spikes and find out what's going on with those spikes. Because if you compare this graph to the kind of graph I usually get on an exam in my classes, quite a difference. If you take a look at the left of my typical graph, there's no spike like there was on that Math 95 graph, which tells us there's a very big difference in the distribution of how these exam grades played out. And that told me to look more closely. What is up with that spike from 50 to 60? So I went and took a closer look at the students who got that 50 to 60. I reached out to them, and I found out what was going on. And it enabled me to get those students the resources they needed to do better in the course. So I guess the point is when you have what's called multimodal data, which is just data that has more than one spike like this one does, maybe consider, instead of just using the things you're used to, the mean or the median, consider the modes, because the modes might actually be telling you something. Now, for those of you sitting there going, oh my God, so there are all these measures of center, but I should use some in certain instances and I shouldn't use some in other. How do I know which one to use when? I get it. I totally get it. What we're going to do is we're going to look at lots and lots of examples as we move through this course and get you better at deciding which ones to use and when. When we start, I'll tell you, calculate this, calculate this, calculate this. But it's a growing process. As you learn more about stats, you learn more about what to use when. Or in some cases, what not to use. So I want to show you a couple examples centered around our hometown of Bend, Oregon, of when sometimes averages get used correctly and sometimes they don't. So I pulled these statements from the visitbend.com website. They're essentially a Chamber of Commerce kind of thing. Get people to show up to Central Oregon and enjoy the weather. And so this is basically a web page about their weather. And there are a lot of numbers, data, statistics, parameters quoted on this page. I agree with some. I completely disagree with others, and some of them are a little bit arguable. Let's kind of poke through here. The temperature one, I don't have actual data to support nor refute it, but my many years of riding my bike in the year-round temperature of Bend kind of supports the statement only 1 year out of 5 has a temperature colder than -17 degrees Fahrenheit or warmer than 100 degrees Fahrenheit. Precip. This is one that I actually have spent a lot of time. So it says if you take a look at the average annual snowfall is 33.8 inches. That's actually spot on. That really is. Snow depth in Bend exceeds 24 inches in only one winter out of 20. I do take issue with that statement, only because, as you see right here, I've actually kept track of snowfall in Bend I've kept track of it for about 20 years, but I've got historical data that goes back about 100. So if you draw a line across 24 inches and you look at how many winners are above that line, that's more than 5%. Remember, one winner out of 20 is 5% of winners. That's a lot more than 5%. Now, how can they be wrong with that statement, but be correct with the average annual? Well, what does an average actually do? I asked you about this in your last homework, and I think we discussed it. An average, when you add up all the amounts and divide by how many there are, what that has the effect of doing is smoothing out the data so that everything has the same amount. That's what the average says. Average 33.8. Take the low winners, bring them up. Take the high winners, bring them down. Smooth them all, and that's what the average is. So yeah, they're actually pretty much spot on with the average of 33.8 inches. The problem with that is, when you focus so much on the fact that that's almost 3 feet, you forget a couple things. The non-mathematical thing is, it's not all there all winter. That's cumulative total snowfall, number one. And number two, there are lots of winters where there's almost no snowfall, and then other winters when you get 5, 6, 7 feet of snow. Overusing an average tends to oversimplify the variability in a data set. We're getting into that tomorrow. Okay, moving on. The sunshine. This is one of my one of my favorite claims about Bend is that Bend has 300 sunny days per year. And I don't know where these numbers come from. Clear days average 158 days with an additional 105 that are mostly sunny. What is the difference between clear and mostly sunny? What makes many of the remaining days provide substantial sunshine? The problem with using the word average here is it implies that something's actually being counted or measured, which I think is stretching the definition of average in this case. And wind, I'll let wind be just because, just like temperature, I haven't collected a whole bunch of data on wind. As a matter of fact, what I have is mostly anecdotal. I noticed they say surface winds prevail out of the south and southeast from October to February, then west and northwest for the remaining months. I would actually counter that due to my own personal experience and the experiences of my buddy who flies ultralight aircraft. The predominant wind in Central Oregon that I've noticed comes out of the south to southwest in the mornings, and then it shifts through the day north-northwest. But that, again, that's anecdotal evidence from me and my buddy. We'd have to look at actual data to see where the averages come from. And let's end with some statistical advice from one of my favorite comedians of all time.
Look at it this way. Think of how stupid the average person is, and then realize half of them are stupider than that.
George, I miss you, I adore you, I still listen to you. But I take slight statistical issue with that statement, and we'll take a look at it in your homework.